Welcome to the 7th lecture on trigonometry. The title of this lecture is Trigonometric Identities for Triple Angles. I remain your lecturer, Professor E.O. Efang. Trigonometric Identities for Triple Angles. Example 1. Prove that sin 3a is equal to 3 sin a minus 4 sin cube a. Proof. Let us recall that sin a plus b is equal to sin a cos b plus cos a sin b. Let us put b equals to 2a, so that this identity will become sin a plus 2a is equal to sin a cos 2a plus cos a sin 2a. That is, sin 3a is equal to sin a cos 2a plus cos a sin 2a. Let us also recall that sin 2a is equal to 2 sin a cos a, and cos 2a is equal to 1 minus 2 sin squared a. Then sin 3a is equal to sin a times 1 minus 2 sin squared a plus cos a times 2 sin a cos a. Let us open this bracket to obtain sin a times 1 is sin a. Sin a times minus 2 sin squared a is minus 2 sin cube a, plus cos a times cos a will give us cos squared a, then times 2 sin a will give us 2 cos squared a sin a. And this is equal to sin a minus 2 sin cube a plus cos squared a is equal to 1 minus sin squared a, then times a. Let us open this bracket to obtain sin a minus 2 sin cube a plus sin a times 1 is sin a, then times 2 will give us 2 sin a. Sin a times minus sin squared a is minus sin cube a times 2. That gives us minus 2 sin cube a. Let us now collect like terms to obtain sin a plus 2 sin a is 3 sin a, minus 2 sin cube a minus 2 sin cube a will give us minus 4 sin cube a. Then we have proved that sin 3a is equal to 3 sin a minus 4 sin cube a. Example 2. Prove that cos 3a is equal to 4 cos cube a minus 3 cos a. Proof. Let us recall that cos a plus b is equal to cos a cos b minus sin a sin b. Let us put b equals to 2a. Then this identity will become cos a plus 2a is equal to cos a cos 2a minus sin a sin 2a. That is, cos 3a is equal to cos a cos 2a minus sin a sin 2a. Let us also recall that cos 2a is equal to 2 cos squared a minus 1, and sin 2a is equal to 2 sin a cos a. Then our identity will become cos 3a equal to cos a times 2 cos squared a minus 1 minus sin a times 2 sin a cos a. Let us open this bracket to obtain cos a times 2 cos squared a will give us 2 cos cube a. Cos a times minus 1 will give us minus cos a. Minus sin a times 2 sin a is minus 2 sin squared a, then times cos a. That will give us minus 2 sine squared a cos a. And this is equal to 2 cos cube a minus cos a minus sine squared a is equal to 1 minus cos squared a, then times cos a. Let us open this bracket, then we will obtain 2 cos cube a minus cos a. Cos a times 1 is cos a times minus 2. That will give us minus 2 cos a. Cos a times minus cos squared a is minus cos cube a times minus 2. That will give us plus 2 cos cube a. Collecting like terms, we will obtain 2 cos cube a plus 2 cos cube a will give us 4 cos cube a. Minus cos a minus 2 cos a is minus 3 cos a. So therefore we have proved that cos 3a is equal to 4 cos cube a minus 3 cos a. Example 3. Prove that tan 3a is equal to 3 tan a minus tan cube a all over 1 minus 3 tan squared a. Proof. We recall that tan is sine all over cosine. So tan 3a is equal to sine 3a all over cos 3a. And this is equal to, we recall that sine 3a is equal to 3 sine a minus 4 sine cube a. And cos 3a is 4 cos cube a minus 3 cos a. Let us break minus 4 sine cube a into 2 parts and also 4 cos cube a into 2 parts as follows. So this will become 3 sine a minus 3 sine cube a minus sine cube a all over, we also break this one into 2 parts as cos cube a plus 3 cos cube a minus 3 cos a. This is equal to, in these first 2 terms, let us factor 3 sine a out so that we will obtain 3 sine a into 1 minus sine squared a, then minus sine cube a all over cos cube a. In these other 2 terms, we have also a common factor, so we factor 3 cos a out, and that will give us cos squared a minus 1. This is equal to 3 sine a cos squared a. Since 1 minus sine squared a is cos squared a, then minus sine cube a all over cos cube a. Cos squared a minus 1 is minus sine squared a. So that will change this sign to minus 3 cos a sine squared a. Dividing both top and bottom by cos cube a, that will give us 3 sine a cos squared a over cos cube a minus sine cube a all over cos cube a all over cos cube a over cos cube a minus 3 cos a sine squared a over cos cube a. In this first term, cos squared a will cancel cos cube a to give us sine a all over cos a here. And here, cos cube a will cancel cos cube a to give us 1. While here, cos a will cancel cos cube a to give us cos squared a here. So this will then give us 3 sine a over cos a is 3 tan a. Sine cube a over cos cube a will give us tan cube a all over cos cube a will cancel cos cube a to give us 1 minus, here is 3 sine squared a all over cos squared a, and that will give us 3 tan squared a. So we have shown that tan 3a is equal to 3 tan a minus tan cube a all over 1 minus 3 tan squared a. The alternative proof. Let us express tan 3a as tan a plus 2a. Then, using the addition formula for tan, this is equal to tan a plus tan 2a all over 1 minus tan a tan 2a. This is equal to tan A plus, recall that tan 2A is 2 tan A all over 1 minus tan squared A, all over 1 minus tan A times 2 tan A all over 1 minus tan squared A. The LCM in the numerator is 1 minus tan squared A. Also, the LCM in the denominator is 1 minus tan squared A. So this will then give us tan A minus tan cube A plus 2 tan A all over 1 minus tan squared A in the numerator, all over 1 minus tan squared A minus 2 tan squared A all over 1 minus tan squared A in the denominator. 1 minus tan squared A will cancel out, so that will then leave us with this: tan A minus tan cube A plus 2 tan A all over 1 minus tan squared A minus 2 tan squared A. This is equal to tan A plus 2 tan A is 3 tan A minus tan cube A all over 1 minus tan squared A minus 2 tan squared A is minus 3 tan squared A. So therefore tan 3A is equal to 3 tan A minus tan cube A all over 1 minus 3 tan squared A. Example 4. Prove that cos 3 theta all over cos theta minus cos 6 theta all over cos 2 theta is equal to 2 times cos 2 theta minus cos 4 theta. Proof. Cos 3 theta over cos theta is equal to, we recall that cos 3 theta is 4 cos cube theta minus 3 cos theta, then all over cos theta, dividing through by cos theta will give us 4 cos square theta minus 3. Also, cos 6 theta all over cos 2 theta can be obtained from this first equation by replacing theta by 2 theta. If you replace theta by 2 theta here, what we will obtain will be cos 6 theta all over cos 2 theta equal to 4 cos cube 2 theta minus 3 cos 2 theta all over cos 2 theta. Or again, dividing through by cos 2 theta, that will give us 4 cos squared 2 theta minus 3. Let us now find cos 3 theta all over cos theta minus cos 6 theta all over cos 2 theta, which is equal to 4 cos square theta minus 3 minus 4 cos square 2 theta minus 3 in bracket. When this bracket is open, you have minus 3 plus 3 will cancel out. So this will then give us cos 3 theta over cos theta minus cos 6 theta over cos 2 theta equal to 4 cos square theta minus 4 cos square 2 theta. But we can express cos square theta in terms of cos 2 theta as, this is 4 into 1 plus cos 2 theta all over 2. That's cos square theta can be expressed as this. Then minus 4, we can also express cos square 2 theta as this. 1 plus cos 4 theta all over 2. If we open this bracket, this will give us 2 into 1 plus cos 2 theta minus, also opening this bracket, 2 will cancel to give us 2 into 1 plus cos 4 theta. When the bracket is open, you have 2 times 1, which is 2, minus 2 times 1, 2. 2 minus 2 will cancel out. So we are left with 2 cos 2 theta minus 2 cos 4 theta. So this is equal to 2 into cos 2 theta minus cos 4 theta. Example 5. Prove that tan theta plus tan 60 plus theta plus tan 120 plus theta is equal to 3 tan 3 theta. Proof. Tan 60 plus theta using addition formula is equal to tan 60 plus tan theta all over 1 minus tan 60 tan theta. This is equal to tan 60 is root 3. So this will give us root 3 plus tan theta all over 1 minus root 3 tan theta. Now, tan 120 plus theta is equal to tan 120 plus tan theta all over 1 minus tan 120 tan theta. And this will give us minus root 3 plus tan theta all over 1 plus root 3 tan theta. Please note, tan is negative in the second quadrant, and tan 120 is equal to minus tan 60. That is why we have minus root 3 here. And minus root 3 tan theta will give us plus root 3 tan theta here. So therefore, tan theta plus tan 60 plus theta plus tan 120 plus theta is equal to tan theta plus root 3 plus tan theta all over 1 minus root 3 tan theta plus minus root 3 plus tan theta all over 1 plus root 3 tan theta. Finding the LCM is 1 minus root 3 tan theta times 1 plus root 3 tan theta. So this will give us tan theta into 1 minus 3 tan square theta plus root 3 plus tan theta times 1 plus root 3 tan theta plus 1 minus root 3 tan theta times theta minus root 3 all over 1 minus root 3 tan theta times 1 plus root 3 tan theta. So this will give us tan theta, when you open this bracket, tan theta minus 3 tan cube theta plus 4 tan theta plus root 3 tan square theta plus root 3 plus 4 tan theta minus root 3 tan square theta minus root 3 all over, please note this difference of two squares, that will give us 1 minus 3 tan square theta, and that will give us 9 tan theta minus 3 tan cube theta all over 1 minus 3 tan square theta. When 3 is factored out here, we will obtain 3 times 3 tan theta minus tan cube theta all over 1 minus 3 tan square theta. And the whole of this expression is tan 3 theta. So therefore, tan theta plus tan 60 plus theta plus tan 120 plus theta is equal to 3 tan 3 theta. On your own, prove the identities. 1. Sin A plus sin 2A all over 1 plus cos A plus cos 2A is equal to tan A. 2. Sin cube A plus sin cube 120 plus A plus sin cube 240 plus A is equal to minus 3 over 4 sin 3A. We have come to the end of lecture 7. Thank you for watching, and keep on watching.